that it's 4 o'clock. Perfect. Welcome to this session. Hope, yeah, you can see the screen. Perfect. So Beyond supports OpenTelemetry, a maturity model for cloud-native observability. Just skipping the additional intro slide here. So I'm Kasper. I work as a Director of Developer Relations at Zero. I'm a former co-chair for KubeCon, Cloud Native Con. I've done a lot of things in this community. Also wrote a book that will be like a QR code at the end if you want to scan that, about OpenTelemetry for sort of getting started. I like to challenge myself, so I also did the Golden Kubesonot last year. A fun little exciting thing to do. The most challenging thing is actually like taking the certificates in the actual system. If any of you are taking those certificates, you probably know what I'm talking about. Also ambassador for CNCF. Just last week it was announced I also got ambassador for the Agentic AI Foundation together with Mauricio here and a few others that are at this event. And yeah, I'm also running similar conferences in the Nordics. In Denmark, the snowflake there is something called Cloud Native Nordics, a meetup alliance across the Nordic countries. So enough about me. I want to talk about observability today and how sort of the ecosystem looks like. And I think this image is probably familiar to some of you, that we have a lot of scattered signals that are living in different browsers, different systems. So maybe you have metrics in one system, you have tracing in another, and logging in a third system. And it's just a growing haystack because our application's getting more and more complex, and it's you as sort of the developer, as the platform engineer, that needs to do sort of the correlation between these different tabs, which is not ideal. Like taking one ID, copying it to the other, trying to figure out what it is, and maybe the names of the things are different. So there's just a lot of like cognitive overload in doing that. And also with this wave of AI, this is probably not what you want to present to an AI as well, because you really want to give it structure so they can actually start to reason about things. And a lot of the projects out there in the ecosystem sort of claim that they support OpenTelemetry. And what does that actually mean? I think that is what I want to talk about in this presentation, because it can mean a lot of different things, and I'll show you that in a second. Because I think we saw this in the early days of Kubernetes as well, where every project needed to like supporting Kubernetes. But what did that mean? That could mean that that was a Docker container that could be put in a manifest, and you needed to do a lot of things yourself. Or it meant that there was a Helm chart available, or a CRD. So it could be a ton of different things. I think the same is currently present with OpenTelemetry, that it means a lot of different things, and we need to, as a community, like start talking about what this actually means and putting it into words. So OpenTelemetry, just for those of you that are not that familiar, you probably have something like this, where you have an OpenTelemetry collector running in your environment, collecting telemetry from your applications, whether they are instrumented using the SDK manually, or you use the auto instrumentation, which is part of the project. There's even operators that can inject this for you. Or it could be that you are observing your infrastructure project. I think that for Kubernetes alone, there's 4 or 5 different receivers for the collector. So you can collect all kinds of different things for Kubernetes, but this goes for a lot of the different projects in the ecosystem, and for the different tools that you're probably using, that might be a receiver that can do that. So you're receiving telemetry in the collector. You can do processing, redaction, all kinds of interesting things that are relevant for your organization, and then you export your telemetry to somewhere, wherever that is. It could be dedicated, as it is with this example, a dedicated time series database for your metrics, maybe something dedicated for your logs, or it could be one solution for all of this telemetry. Then you, of course, start to analyze your data on top of that backend. But OpenTelemetry is really focusing on sort of this first part, on the collection part, on standardizing how we are collecting telemetry and what things are, and we'll come back to that. So basically, you produce, or your projects that you're using are producing telemetry. You can do this, as I mentioned, by either automatically with the auto instrumentation, or you can do this manually. OTLP is the wire protocol, sort of it's the OpenTelemetry protocol that is basically sort of the contract between the SDKs or whatever that are producing the telemetry and the receiving part, which is the collector in this case. And this is where you build the shared plumbing, as I mentioned. In order to make all of this meaningful, you need semantics. You need to like apply meaning and agree of what these things are, and this is where the semantic conventions comes into the picture. It's really the community coming together, defining what things are, what values they can take, which is a really, really nice thing. It's also resource attributes. I basically providing identity to whatever's producing your signals, and I'll come back to that in a later slide. And then it's about context. It's about, I'm starting a trace, and now I'm registering this span, and that needs to be propagated. So it's really the contract of how we're producing telemetry and how we are forwarding and propagating that through our system. So just quickly that, telemetry without context is just data, right? And what do I mean by that is that if we see something like this, just a graph, what could this be? It could be anything, right? It could be HTTP requests, it could be, I don't know, approval ratings of a US president or whatever. It could be anything because we don't know. But in this case, it's basically how cute an animal is versus the number of legs that it has. So the context really, really means something when we're looking at data in general. And how does this then apply to systems that we are working with in this sort of part of the world is that we have different layers, right? We have the infrastructure, we have platform, we have the compute layer, we have the architecture itself, so the service names and all that, but also the organizational part who actually owns the service. So all of this is context around the applications that we are running. And luckily, the OpenTelemetry project has semantics for all of this. So all the way from the bottom to the top level of the stack, except organization. I know there's a lot of work in the community around adding something like owner to the service, but you can do a lot of things yourself by creating and using the project called OpenTelemetry Weaver, where you can define these things yourself and create your own semantics on top, which is quite nice. But just know that there exists a lot of semantic conventions for probably whatever you need out there. So resource is basically, so I'm starting with the resource because that is really sort of the identity of where things are coming from. And concretely in OpenTelemetry, you have this resource object or these resource attributes that define what your service is. So it has a service name, it has a service namespace where it's running, it has a version, it might have contain some information about the environment that it's running in. It's a Kubernetes cluster, it's this part, and it's this namespace. The problem in this from the maturity perspective is that a lot of this comes from downstream. It doesn't come from the source itself. So it's not the actual application running inside the pod that is generating this. It's something that you add in a pipeline. So that means that we are pushing a lot of things into the configuration of the collector rather than this just being generated from the get-go, from the project itself or the application itself. Yeah. OpenTelemetry, awesome project, just graduated. This is just to sort of put it up there and why it's important. It is the second largest project within the ecosystem. It also has a huge adoption across the industry. This is from the CNCF report that was published in January, where 49% of all respondents are running it in production, and an additional 26 is evaluating it. And it just graduated a couple of months ago, a month and a half ago. So it is becoming more and more important. It's actually becoming this sort of foundational infrastructure and contract between our services, our ecosystem, things that you're using, and the telemetry backend that you're using. So that also, of course, raises the expectations that you probably have as platform engineers, as, I don't know, SRE infrastructure, whatever your title is, that this is just a thing that should work. You take it down the shelf, you plug it in, and you expect it to work out of the box. You expect it to speak the shared language, understand the semantics is there, they're updated, and that should also be a stable, predictable, basically schema that you follow, so that you know when something is being upgraded, you have a good path and you understand that path, so that you don't have dead dashboards because now this version was upgraded, etc. But in reality, unfortunately, sorry to disappoint you, it's a little bit scattered out there. If you look at the CNCF ecosystem in general, I think many supports OTLP, which is the wire protocol. It's not really sort of the product pluggable experience that you expect as a platform engineer, which is kind of annoying because that means that you will need to deal with a lot of things in your collectors, in your pipelines, where you need to have a lot of this configuration instead of this just coming out of the box from the services itself. So the collector becomes this compensation layer to some extent, right? That you put in some configuration. You probably have, for each of the different tools that you're using, you have maybe a specific rule that you tailor to this because you needed to extract this, or you needed to rename something, or whatever it might be. And you probably also just add in this KDS attributes processor, which adds like Kubernetes metadata to your telemetry. But this should come out of the box from all the services that you are running, rather than something that you need to compensate for in your collector. It can be all kinds of things that you are adapting. Maybe the project does not support semantics. Maybe it has its own semantics, and you want to convert them or do something with them so that they actually align, which is not ideal. And then this is an example from one of the, I did sort of an evaluation of 5 ingress controllers, and this is an example from Contour, where you basically you set up, I want tracing to be exported, I give it a service name, that's fine. You tell it where the collector is running, that's also easy. But the problem is that the only export was to via OTLP was the tracing. So logging was basically standard out, as we all know, collected with, I don't know, in this case, the file log receiver in the OTel collector. So, and that didn't even include the trace parent. So I didn't have any way to correlate the actual logs with the traces. Luckily, they had like, I can add my own sort of format so that I can include the trace parent. And then in my collector, I need to basically extract that, split the trace parent because it includes the trace ID and the span ID, and set them correctly on the record itself. This is not ideal, right? This should be something that comes out of the box, rather than me having to figure out how to extract things and use the OTTL transformation language to actually set these values. So you are kind of paying the bill as platform engineers. And if you have a lot of services, you probably have like collector sprawl, a lot of YAML lines that you need to maintain, and that is probably not ideal. And of course, this also impacts your dashboards, because your dashboards are built on the metrics that you're collecting. So whenever you're changing something, you need to make sure that everything is sort of like the full pipeline is end-to-end is updated as well. And that might hurt your MTTR if you're, I don't know, expecting something and then it's something different the other day. So it's not ideal as it is right now. So what does the ecosystem has to offer from this perspective? Well, there's like Ecosystem Explorer is a fairly new project that allows you to basically explore the ecosystem of OpenTelemetry. What options do I have? Right now, it's only focused on the Java instrumentation, and OpenTelemetry Collector is also coming right now, coming soon. So they're working on making it easy to understand what it is, what the different parts of the ecosystem is producing. And then we have Instrumentation Score, which is more about basically like evaluating your telemetry that is coming out of the services, and basically give you a score of from 0 to 100. So we are missing sort of this design intent. We are missing sort of the maturity, the versioning, and all of these things that we expect as platform engineers in a world where this is a graduated project and where things should just work out of the box. So I proposed this OpenTelemetry Support Maturity Model back in February, I think. I can't even remember. It's been a long time. And the idea behind this was basically to try and come up with different levels of, okay, how well is this, how mature is this, from a scale from basically 0 to 3, which is from, okay, this barely does anything, to this is very optimized, this is following everything, best practices around how things should be mature in an OTel world. But not only looking at like from 0 to 3, but also looking at different dimensions, because there's a lot of different ways to sort of evaluate telemetry, especially when you have multiple signals. So I split this into what I call dimensions, which was basically semantic conventions, resource, attributes and config, trace modeling, multi-signal, observability. So a lot of different dimensions. I'll not go into all the details on this, but just know that within each of these, you could sort of grade it from 0 to 3 and sort of get an idea of how is the project, how mature is it. But I didn't want to like the idea with this wasn't to create a scoring system. It was basically to have a conversation about how mature is this? How can we improve? How can we help the ecosystem? How can we help the maintainers with some recommendations on this is how you could improve. So just 2 examples. So from a resource perspective, as I mentioned in the beginning, it would be something about, okay, this is something that just accidental come into it's maybe it's a binary, maybe it's something that basically just generates the service name, to in an OTel optimized world where basically all of this is following the semantics, everything is populated out of the box. It's also about does it actually emit the KDS resource attribute by itself? Is it something that it can do by itself? And this is very easy to do in the OTel world because the SDK has resource, basically ways to do that very easily. In the ingress evaluation that I mentioned before, we have, I can show you all the scoring or sort of the visual in a second, but traefik basically has this that comes out of the box, whereas all the rest of them, it was partial support for this. From a semantic conventions perspective, this is the same, again, evaluated from 0 to 3. What I saw in this test was basically that all the Envoy-based ingress controllers were out to date, not up to date with the latest semantics because, well, Envoy wasn't up to date with the latest semantics, so that sort of ripples downstream to all the ingress controllers relying on it. However, they were supporting semantics, semantic conventions, which is a good thing, but there wasn't really the latest thing. So it's a start. But basically, it's about, so this is very project-specific things to actually following the semantics and creating your own semantics using OpenTelemetry Viva or something else. So that's sort of the scale we are working at. So this is just ingress controllers, the 5 I evaluated. This is the differences that you see when this is plotted into a sort of a radar diagram. And as you can see, there's very different shapes of how these projects are evaluated based on this maturity model. So the support out there is very varying. And even from just looking at the number of metrics that are exported in some of these. So this is sort of telemetry or basically metrics from each of the different ingress controllers. And as you can see up here, Contour is outputting 486 Envoy metrics, which is quite a lot. It might be a good thing, it might not be. From my perspective, at least, I think we are forgetting a little bit that we should, as project maintainers or creators of projects, we should design for the actual end user. And in many cases, the end user is a platform engineer, right? Not the maintainer itself. And I don't know what is the right level. It can be, it needs to be whatever is right for the actual users of this project. But it's just interesting to see from 11 metrics to 486 metrics around ingress. So basically, they have very different shapes. Only one is sort of what I would define as OTel native, end-to-end, which was traefik. Metrics is still, in many of these, only supported using Prometheus, which is fine from that perspective. But I think when we are moving into a world now with OpenTelemetry, it's really nice that we now have also for metrics, we have units, we have real semantics, and we know what things are instead of that underscore best practices thing we have in Prometheus. Resource identity, as I also showed you, is still leaking into your pipeline, where you have to do a lot of this configuration. So the example with Contour, I had to do that for 2 of the others as well. So something similar where you need to log it and you need to extract and actually transform this in the pipeline. Stability is not a thing in any of these really. There's no, this is how we are upgrading our telemetry, this is how we are versioning this, nothing. So, and they all support OpenTelemetry, so it's an interesting ecosystem to look at, and this is only ingress. I haven't looked at other systems yet, but it's just to say that take a little bit of a deeper look into the projects that when you're evaluating and actually understand what it is they're producing, because it might vary and you might need to do a lot of things by yourself. So this was proposed as a community proposal to the OpenTelemetry community. It started as this, basically this comparative maturity score that I showed you, but the OpenTelemetry community is not really liking the idea of having this score, which makes sense. The project don't want to be like an assessment of other projects. So I think a lot of this work can be then translated into some self-assessment tools for different projects, so that they can run this and get an evaluation, so that they can start like implementing and improving the maturity in the community. And then of course, like helping out with other things, like providing guidelines for the 7 different dimensions on how to actually do this probably as a maintainer of a CNCF project. So I think even though that this model is not going to be like a full model that's going to be implemented in the ecosystem, there's a lot of interesting work that has come out of this in order to improve the overall maturity of the ecosystem. Yeah, so this was basically this. We right now it's gonna start living under the SIG comms, which is where we are like taking this discussions even further. So if you wanna join, feel free to like look at the different resources. We are trying to do whatever we can to improve the maturity in general, and figure out what is best for maintainers, what is best for the ecosystem itself, and what is best for OpenTelemetry as a project. And I think OpenTelemetry is sort of also the foundation to sort of this AI SRE kind of thing that we are all probably like evaluating, trying to figure out how to use and get most value out of. Because yeah, let me just jump on, because AI, we are probably all like trying to get these AI SRE agents trying to understand our telemetry, but the problem is that if you don't use something like OpenTelemetry that comes with semantics, that comes with all of this, you just put in like inconsistent fragmented data into an LLM. You don't get much like interesting out on the other end. You're probably just like automating confusion a little bit and scaling that faster. So it's also just to say that if you really want to use these AI tools to like get incident resolution faster, etc., like really consider using OpenTelemetry, because you have the semantic conventions, so you have the standard, you have the specs, you have everything. Basically everything is defined what it is, what units it can take, and then if your telemetry is conforming to that, AI can really start to actually reason about the telemetry. Yeah, so without convention, correlation fails. Without correlation, AI guesses. With structure and context, AI reasons. So what I want to say with this is basically that we need to raise sort of the maturity of the ecosystem in order to also like get really good value out of sort of this next wave of AI SRE that we are like facing right now, because that is really the foundation of a lot of this. But also, if you want to understand what your Gen AI workloads are doing, you probably there's semantic conventions for that as well, which is nice. They're also like there's a lot of stuff going on in that ecosystem right now, changes, etc. But it's better to have like a standard where we are as a community defining what things are, even though it evolves pretty fast. But you can get a lot of cool insights into what your AI workloads are doing, etc. And then you can, of course, also use your AI SRE assistant to understand that telemetry to what the actual agent that you have running is actually doing. The problem, though, is this ecosystem is not mature either, right? Because we have a lot of different specs out there trying to create, and I think this is fine. Everything needs to start somewhere, right? If things are like being like invented in different communities around the ecosystem. But the problem is now that we have 5 different ways of specifying what a model name is. We are going to have again issues in actually utilizing our AI SRE thing to understand what is going on. So I'm hoping to see that we are conforming on OpenTelemetry as this vendor neutral way of defining also Gen AI workloads. But in the meantime, there's some cool projects out there that you should check out if you are like working with instrumenting your AI workloads. So the Gen AI normalizer is Basically, it's a processor that you can put into your OpenTelemetry collector that allows you to send in any of the 5 different formats that you saw before, and then it will transform that into GenAI semantic conventions. So it is a way for you to still allow your developers or whatever to test out these different tools, and then you can conform on a standard in your collector. I know this goes a little bit against what I said in the beginning, that everything should come from the source, but it's a way to sort of deal with this complexity as it is right now. There's also another cool project if you're running in the using Spring and in that ecosystem. Actually, a Danish friend of mine, Thomas, created this cool thing called Arconia. It allows you to set a config variable in your config to basically say, I want this semantics out. It should be OpenTelemetry, or it should be open inference or whatever. You can control that as you want to, which is kind of cool. So where are we going in this ecosystem? I think we've done a lot of this before, right? Kubernetes got like this conformance program. That was the Sonobui thing that Heptio created back in the 2017, something like that, to basically create this certified Kubernetes service providers, all of that to sort of evaluate how people were like building these things. I think the Prometheus community did something similar. I think it would make sense if there will be like a conformance program for OpenTelemetry as a project, both towards the projects in the ecosystem, but maybe also towards the vendors, so that you as a platform engineer or whatever really have something to rely on when you're selecting either vendors or projects out there. So we'll see. We are not there yet. So if that is something that you find interesting, please feel free to ping me as well. I'm very interested in these topics and trying to drive the community in that direction as well. That was about what I had to say today. If you want a free copy of the OpenTelemetry for Dummies book, feel free to scan this QR code. Just waiting a few seconds. I can see people are taking out their phones. Have more QR codes, so if you if you want a shirt like this or enter a competition, there will be a slide afterwards, so you can bring out your phone. So because there's another QR code. It's a pretty cool like football jersey, and the World Cup is going on right now. I know it's Danish colors, which is actually quite nice because I'm a Dane. But yeah, you can enter the competition here. And just the last shout out here is to Merge Forward. I'm not sure how many of you knows this, but basically this is a community under the CNCF to basically help create a sustainable open source ecosystem with all the diverse groups that are existing out there. So check out the QR code if you want to know more about that as well. And with that, I want to say thank you for attending. Yeah, ping me if you want to. That was maybe a bit far. You can find me. And please leave some feedback for this session. And with that, thank you so much for attending. We have 1 minute, maybe. So one question, if there's any. Otherwise, I'll be here the rest of the day also. So feel free to stop by me. I'm pretty easy to find in the red shirt. Cool. Doesn't seem like it.